Добрый день, уважаемые участники Международной молодежной научной школы исследований космоса, теории и практика. Сегодня третий день работы нашей школы. И сегодня у нас запланирована встреча с удивительным человеком, уникальным человеком, который является историей в мировой космонавтике, который был с 1996 года по 2001 год руководителем, директором космического центра Джонсона, НАСА, и который является в настоящее время старшим научным сотрудником по космической политике Института Бейкера, Университета Райса, мистером Джорджем Эбби.
Hello, dear participants. Today we have a third day of our workshop, the Space Development Theory and Practice. This is the International Summer School, and today we are going to hear the lecture from our distinguished guest, a person who represents a history of space exploration himself. This is Mr. George Abbey, who was a director of Johnson Space Center, NASA, from 1996 till 2001, and who is now the senior fellow on space policy in James Baker Institute of Rice University in the United States. So, Mr. Abbey is a very famous man in the space industry, and we are very happy that we have an opportunity, I would say a unique opportunity, to listen him this day.
И сегодняшняя лекция прозвучит из уст человека, который не только был участником программы «Аполлон», а был еще и руководил этими космическими миссиями, космической миссией Аполлонов. Это единственные полеты, при которых человек высадился на Луну.
Mr. George Abbey, not just a man from a space industry, he was not just involved in space operations, but he was a staff member of the ground support for the Apollo space flights. And just to remind you that the Apollo space flights are very unique because this is the only example of human space flights toward the moon.
И у нас сегодня есть уникальная возможность послушать, как это было от человека, от первого лица.
So today we have a unique opportunity to listen how was it, how the things happened from a man who participated in all this job, who knows many things in details, and this man is Mr. George Abbey.
Пожалуйста, мистер Эбби.
Mr. Abbey, please, the floor is yours.
Well, thank you very much. It is a real pleasure to be a part of the workshop this morning.
Без перевода.
So it will be without the translation, so please don't interrupt yourself.
I thought I would talk to you a little bit about the Apollo program, as Victoria said, and how the Apollo program got started. The space program, as we have understood it, we know it today, really got started when the Soviet Union launched the first manned satellite into Earth orbit on October 4th of 1957. And that was a great achievement and caused a great deal of excitement and consternation in the United States and the Western world, because if they could do, the Soviet Union had that kind of capability, they obviously had very good advanced technology, and they could do much more than just that. So it caused a great deal of excitement and interest in the Western world, and the United States was really determined to try to form a group of people that would focus spaceflight and try to achieve, ultimately achieve flights into Earth orbit. So that summer of 1958, the Congress of the United States approved the formation of the National Aeronautics and Space Administration. And it was formed on October 1st of 1958. And at the same time, the Soviet Union had progressed and flown a Sputnik 2 with a dog, and they were also looking ahead to flying humans in space as the selected cosmonauts. And in December of 1958, the United States announced the Mercury program, and we started the selection process to select 7 astronauts that would ultimately fly in the Mercury program. And here you see the 7, Alan Shepard, John Glenn, Gus Grissom, Scott Carpenter, Leroy Cooper, Wally Schirra, and Deke Slayton. And they were all selected to ultimately fly the Mercury program. And that was in 1959, and the president of the United States at that time was Dwight D. Eisenhower, and he gave in to a lot of pressure to get NASA formed. He was not an enthusiastic supporter of manned space flight or necessarily humans flying in space, and was not a great supporter of NASA, but the pressure of the Congress and the public pressure really forced him to go ahead with the formation of NASA, and then ultimately the selection of the Mercury astronauts. And the program progressed, and in 1960, we had an election. President Eisenhower had finished his second term, and we had an election in November of 1960 between Richard Nixon and John F. Kennedy. And John F. Kennedy was selected as the President of the United States, and he came into office in January 1961. And when he came in, he was with a lot of fanfare and a lot of interest, and he had been making a lot of promises about what he would do relative to technology and research. And so there were great expectations that President Kennedy and his administration would really move forward, and we would be able to compete on a better basis with the Soviet Union. Well, he came into office in January, and 3 months later in on April 12th, 1961, he saw the first human go into space, Yuri Gagarin, and that flight caused even more consternation in the United States than Sputnik had, because it obviously showed that the Soviet Union had a tremendous capability, and flying Yuri Gagarin as the first human in space was a great achievement. About 5 days after the flight of Yuri Gagarin, there was a aborted effort to invade Cuba. The United States had supported some Cuban exiles to invade Cuba and overthrow Fidel Castro, and that turned into a disaster. So within 3 months of coming into office, President Kennedy was embarrassed by these two major events. He had formed a group called the National Aeronautics and Space Administration Council, and it was it was formed under the leadership of Vice President Johnson. And on April 20th, after Yuri Gagarin's flight and after the Bay of Pigs, he wrote a memo to the Vice President. And this is a copy of the memo. and he asked him some very pertinent questions. In the first paragraph, he said, do we have a chance of beating the Soviets by putting a laboratory in space, or by a trip around the moon, or by a rocket to land on the moon, or by a rocket to go to the moon and come back with a man? Is there any other space program which promises dramatic results in which we could win? And then he filled out that memo with some additional comments. So the vice president came back with recommendations. At that point, the United States had not flown anyone in space. And he came back with recommendations to the president. And on May 5th, 1961, the United States launched Alan Shepard on the first Mercury flight on a small Redstone booster that went downrange about 230 miles downrange from the launch site in Florida, and went up to an altitude of about 101 nautical miles. It was a flight of about 15 minutes. So it wasn't an orbital flight, and certainly was well behind what Yuri Gagarin had accomplished in April. But the president took that recommendation from the vice president, and on May 25th, 1961, this is Alan Shepard and his wife, and President Kennedy and his wife, and the vice president at the White House after Alan Shepard's flight. And on May 25th of 1961, President Kennedy spoke to a joint session of the United States Congress and announced at that time, on May 25th of 1961, that the United States was going to go to the moon and bring astronauts, land astronauts on the moon and safely return them to the Earth, and do that by the end of the decade. And that was quite a major step forward for the United States. And at that point in time, NASA and the space industry in the United States had really no idea how they were going to do that. But he laid down the challenge, and so we were forced at that point in time to try to figure out how we were going to accomplish a mission to the moon, land astronauts on the moon, and return them safely to Earth, and do it by the end of the decade. There were three different approaches that were being considered by people in the United States at that time: a direct ascent to the moon with a large rocket. It landed on the moon and then would take off from the moon. But that was a very, very large rocket and would be very expensive and take a long time to build. The other approach was Earth orbit assembly, where you would assemble rockets in Earth orbit and join them together and make a large rocket, and then go to the moon on that large rocket and do pretty much as you would with the large rocket that is launched from the Earth. Both of those approaches were being considered very, very strongly by the leadership in NASA. But a young engineer at Langley Research Center, had been a part of the National Advisory Committee for Aeronautics. When NASA was formed, it was formed by taking the National Advisory Committee for Aeronautics, a group of 5 research centers that were involved in aeronautical research primarily, but also some space research. And then they took the rocket engineers that had been working for the Army under Von Braun at Huntsville, and they formed NASA. So this individual was a young man who was working at Langley Research Center, and he came up with an approach that was called Lunar Orbit Rendezvous. And he couldn't get anyone to listen to his approach. So he wrote a letter to the Deputy Administrator of NASA, Bob Siemens, wrote him directly and bypassed all the channels, and said that he had a approach, Lunar Orbit Rendezvous, and it was really a better approach than any of the others, and it ought to receive some consideration. Well, Siemens gave it to some of the individuals that were running the space program at NASA headquarters, George Low and Joe Shea, and they looked at this approach, and both Low and Shea thought it was a very good approach. And Joe Shea set about to convince Werner von Braun and Bob Gilruth, who was running the the Mercury program and was going to be the director of the Johnson Space Center, the first director, convinced them that lunar orbit rendezvous was the right approach. And he was very successful in doing that. And in July of 1962, about a year after President Kennedy said we were going to go to the moon, we had finally arrived at an architecture that we would use to go to the moon. Lunar orbit rendezvous would be a launch of a rocket that would carry a command module, and it would also carry the landing module that would land on the moon. They would all be on one rocket, and they would be launched together, go into Earth orbit, and then the vehicle that landed on the moon and the command module would be launched on a trajectory to the moon by the third stage of a large booster, the Saturn V. And then the command module would dock with the lunar module, and then they would fly together to the moon. And once they went into lunar orbit, the lunar module would go down to the surface of the moon, and it had two stages. And the first stage was the landing stage, and the second stage was the ascent stage. So they would do their landing, and then the ascent stage would be used to come back up into lunar orbit, where the command module would be orbiting the moon with one of the astronauts, and two of the astronauts were in the lunar module that had landed on the moon. They would come in and launch from the moon, rendezvous with the spacecraft in lunar orbit, and then they would leave the lunar module in lunar orbit and return to Earth in the command module. This approach, though, really required a lot of rendezvous. It required docking, and the Apollo spacecraft also required new systems, fuel cells and other systems that were not flown on Mercury. So it was determined that we really needed to start another program, Gemini, a two-man vehicle that would allow us to do rendezvous and dockings in space, because a Mercury spacecraft didn't have that capability. And so we finished the Mercury program and flew 6 flights on the Mercury program. We flew finally in orbit. John Glenn flew in orbit in February 20th in 1962, well after President Kennedy had said we were going to go to the moon. But he was the first orbital flight performed by an American astronaut. And then subsequent to that, Scott Carpenter flew, and then we flew the other Mercury astronaut. And the last flight of Mercury flew 22 orbits around the Earth. So we still had a lot to learn. We had to prove that humans could last in space for the duration of a lunar mission. And we had to really develop the techniques and the processes for doing rendezvous and dockings, and develop the fuel cells that we would need for the Apollo spacecraft. And that was all done on Gemini. And Gemini first flew in March of 1965. It flew right after Alexei Leonov had flown on Voskhod and done the first EVA in space. And that was done just before the first flight of Gemini. And back in those days, we wanted to try to equal what the Soviet Union was doing. So on the next Gemini flight in June, we did an EVA also on Gemini. But that was one done after Alexei's EVA in March. We flew 10 missions manned missions in Gemini, and we did a number of rendezvous. We did a number of dockings, and the program also involved EVA activities. And it was a very successful program, and really we would never have been able to get to the moon had we not done Gemini. It was a key step, and the systems we developed for Gemini, the fuel cells and the other systems, we carried over into the Apollo program. And so with the confidence we had from Gemini and with the development of the systems that we had developed for the program, we were able to proceed with Apollo. The last Gemini flight was flown in November 1966. And the Apollo program had been progressing, and the first flight of Apollo, the first orbital flight in Earth orbit, was Apollo 1. and it would be flown in February of 1967. And in this picture, it was you see the command module. The command module is the capsule that is on the top of the cylindrical section there. The cylindrical section is called a service module, and it had a propulsion engine at the aft end. And it also had all the electrical systems and the expendables for the command module. It had the fuel cells and the oxygen and all the other expendables that supported the command module. So this was going to be the first mission of Apollo, going to be a manned mission. And it was going to be flown by 3 astronauts, Ed White, who had flown on Gemini, and Gus Grissom, who had flown on Mercury and Gemini, and an astronaut, Roger Chaffee, who had not flown in space before. So usually before we do a launch, we do a countdown demonstration test in Florida before we do a launch, which is a dress rehearsal for the launch. And in January 27th of 1967, we were doing a dress rehearsal, a countdown demonstration, getting ready for the launch of Apollo 1 in February. And we had the 3 astronauts in the spacecraft, and the hatch was closed, and they were in their spacesuits, and it was a dress rehearsal as it would be for just a normal launch. This is a picture of the 3 astronauts, and this is a picture of their spacecraft when it was going through processing. They were on the launch pad and in the spacecraft, and we of course were flying on Apollo with 100% oxygen. And because we felt that there was a need to have Velcro inside the spacecraft, there was a lot of Velcro, nylon Velcro inside the spacecraft, so the astronauts could attach different things to the surface and not lose them when they got into orbit. So there was a lot of nylon Velcro in the spacecraft and a lot of flammable materials. The hatch was closed, and the astronauts were going through their test, and suddenly there was a spark and a fire inside the spacecraft, and the astronauts tried to get out of the spacecraft. We had at that time an inward opening hatch, and the astronauts tried to get the hatch open, but an inward opening hatch was just too difficult for them. And they didn't burn to death, but they suffocated when the fire extinguished, burned through their oxygen hoses on their suit. So we lost all 3 astronauts. The pressure built up in the command module and it ruptured. So we had a major disaster with Apollo 1. And that was in January of 1967. And the end of the decade was coming up fairly soon. So what we had to do at that point was really to try to understand what had caused the fire. And also, once we understood what caused the fire, we had to look at really getting materials inside the spacecraft that would not burn in 100% oxygen. So we really determined, I think, the cause of the fire. I think the insulation on the wiring, because people had been not careful going in and out of the spacecraft, and it damaged some of the wiring in the command module. And the insulation was gone, and there was a spark, and that spark created a fire when it caught the nylon on fire, and the fire progressed from there. So with that understanding, and then we had to really do a major effort to come up with all kinds of new materials. And so we started a major effort trying to develop materials that did not burn in oxygen, and just about everything burns in oxygen. So it was a major development of materials. We had to develop new Velcro, we had to develop new spacesuits, so everything that was in the spacecraft would not burn under the 100% oxygen. So that was a major effort, and that took a good while. And we also had to redesign the hatch, of course, because an inward opening hatch was not the right kind of design. So we designed a very quick outward opening hatch that worked very well. And we also took the occasion to do a review of all the systems in the command module and improve their reliability and redesign them where we could to improve them. And so that was a major effort that we undertook from the time of the fire in January '67 and all through until the next year in 1968. And we had finally got to the point where we felt we could fly again. The spacecraft, the first spacecraft, was going to be flown in October 1968. This is that spacecraft. This is Apollo 7. It was going to be flown by Wally Schirra, Don Isley, and Walt Cunningham. Schirra was a veteran of Mercury and Gemini, and Isley and Cunningham had not flown before. And it was going to be a flight of just a command and service module. You see here the command module is that capsule on the front. The service module is the cylindrical section, and then the propulsion of the engine on the aft end. So this is a very important flight because we couldn't really progress beyond this unless we could prove the command and service module could operate and operate well. So that was a flight that was scheduled in October, and at that point I was working for George Lowe, who was at that point was the Apollo spacecraft program manager. And in August of that year, he took vacation. He had been working pretty much 7 days a week, nearly 24 hours a day. So he took off a couple days to go on vacation. It was a well-needed vacation. And he came back and he told me that he had thought about the plan that we were on, and he said that if we continued on the present plan, we were not going to land on the moon successfully by the end of the decade. We had to do something differently. So he had decided that he would try to convince NASA management that if this flight, Apollo 7 with the command and service module, was successful in every regard, that he would take the same command and service module to the moon 2 months later on Apollo 8. And that was a major step forward to take a spacecraft that had not flown in space before and assume that it was going to work well and then take it to the moon and fly in orbit around the moon. It was a major step forward. But he convinced the NASA management, he convinced Von Braun and Bob Gilruth, and he had a more difficult time for convincing Jim Webb, who is the administrator of NASA. But they finally agreed that if Apollo 7 was completely successful, they would do a review in November, and then if they decided based on the results from Apollo 7, they would go ahead and decide to go to the moon on Apollo 8 in December. Well, Apollo 7, as it turned out, was very successful. Here's the 3 astronauts that flew on Apollo 7. And this is the launch of Apollo 7. It did not fly on a Saturn V. It flew on a smaller version of the Saturn, a Saturn 1B. In it was just going into Earth orbit. And it was very successful. And this is a picture taken by the astronauts in Earth orbit over Florida, and you can see the whole peninsula of Florida. You can see where they took off from at Cape Kennedy. And this was one of the best pictures of Florida that we've ever made. So the mission was very successful, and it was concluded that we would then be in a position to go to the moon on Apollo 8 with the command and service module. But there was another problem that had been occurring in parallel to this. You needed a Saturn V to get to the moon on Apollo 8. And the Saturn V had only flown 2 flights. It flew a flight in November 1967 that was very successful. And then it flew a flight in April of 1968, which was not so successful. On the first stage, it had major oscillations that would have been very severe for the astronauts and went beyond the design criteria. And then on the second stage, 2 of the engines failed. And in the third stage, the engine that had to be restarted to take us on a trajectory to the moon wouldn't restart. And then over and above that, the area that was around the lunar module, the area that's around where the lunar module would be, came apart in flight. And so we had to really understand what caused that, what caused the oscillations, what caused the failure of the engine. So we had to fix all that, why the engine didn't restart. So that was all that effort was going on in parallel as we got ready to fly Apollo 7. And so the rocket engineers convinced themselves that they had solved all the problems and tested them to prove that they were solved. And so it was agreed that we'd fly the next flight of Saturn V would be supporting Apollo 8. So the third flight of Saturn V after the very bad flight in April would be flown in December, and it would be flown with humans on the Saturn V. And so we did proceed to December, and Saturn V did perform well. This is the patch of the crew. Frank Borman was a commander, and Jim Lovell and Bill Anders were the astronauts. Borman and Lovell had flown before, and Anders had not flown. This is a picture of the three astronauts. And this was the launch of Apollo 8. It was launched on December 21st. And it was a very successful launch. The Saturn V worked very well, even though it hadn't worked that well on the previous flight. And this is a picture that was taken by the astronauts after they fired the third stage. The third stage, we went into orbit with the command and service module, the lunar module, and the third stage. The third stage was used to put us on a trajectory to the moon. And then we'd separate from the third stage, and the command module would do a 180-degree turn and dock with the lunar module and pull it out of the adapter section where it had been housed above the third stage. And this is a picture taken of the Earth on their way to the moon. You can see South America, and you can see North America to the left. And this was a great picture. We had never seen the Earth from this view, and it was an astounding picture. And the crew got into orbit. They orbited the moon on December 24th, Christmas Eve. And this is a Christmas message that they made on Christmas Eve in 1968.
We're now going over approaching one of our future landing sites, selected in this smooth region to solve the Sea of Tranquility. Smooth in order to make it easy for the initial landing attempt, in order to preclude having to dodge mountains. Now you can see the long shadows of the lunar sunrise.
This is the first time we saw the moon close up. And this was Christmas Eve, and they were reading from the Bible.
We're now approaching lunar sunrise, and for all the people back on Earth, the crew of Apollo 8 has a message that we would like to send to you. In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light. And God saw the light, that it was good, and divided the light from the darkness. And God called the light day, and the darkness he called night, and the evening and the morning were the first day. And God said, "Let there be a firmament in the midst of the waters, and let it divide the waters from the waters." And God made the firmament, and divided the waters which were under the firmament, the waters which were above the firmament. And it was so. And God oily earth, and the gathering together of the waters called he seas. And God saw that it was good. And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
That was a very emotional evening, Christmas Eve of 1968, for all of us in the control center, looking out and seeing the television pictures they took out the window of the moon and having them read from the Bible on Christmas Eve. It's just a highly emotional evening. And of course, the mission was very successful. They orbited the moon, and then they were able to depart from lunar orbit and return to the Earth, and the mission was quite successful. And we then had to prove the lunar module. We had proven the command and service module, but we still had to prove the landing vehicle that would land on the moon. And so the next mission, we flew the next mission 2 months later. We were flying these missions 2 months apart. And we had to, if there were any problems that occurred on the mission, we had to fix all the problems, get that all redone and redesigned and incorporated in the spacecraft in time for the next mission and within 2 months. So the next mission was going to be Apollo 9, and it was going to involve both the command and service module and the lunar module. And the crew on Apollo 9 would have to learn to fly 2 spacecraft. They'd have to learn to fly the command and service module, but they'd also have to learn to fly the lunar module. And Apollo 9 was launched on Saturn V. This is a crew of Apollo 9, Jim McDivitt, Dave Scott, and Rusty Schweikert. And Apollo 9 was launched in March. And this is the launch going up into orbit. And Saturn V again worked very well. And once they got into orbit, 2 of the astronauts went over into the lunar module. We were in Earth orbit. And 2 of the astronauts went in and crewed the lunar module and separated from the command module. Dave Scott stayed in the command module. And he took this picture of Jim McDivitt and Rusty Schweikert in the lunar module as it separated. We separated by a couple 100 miles and then re-rendezvoused with the command module and then docked again with the command module, just as we would be doing on a mission to the moon. We also did an EVA with a spacesuit we used on the moon, a partial EVA out the hatch window, out the hatch. And this is Rusty Schweikert standing up, extending out by the hatch, and that's a quick opening hatch we redesigned. So the mission was quite successful, and we had proven the lunar module, and we had proven the spacesuit, and we had proven our ability to rendezvous and dock. So the next mission we'd fly was 2 months later, and that was flown in May, the early part of May. That was Apollo 10. And the crew of Apollo 10 was Tom Stafford, who was later to be the commander of Apollo Soyuz, John Young, and Gene Cernan. All these 3 astronauts had flown on Gemini. John Young had flown the first Gemini with Gus Grissom, and Tom Stafford and Gene Cernan had also flown on Gemini. But this mission would be a mission to the moon. We would go into lunar orbit, and Tom Stafford and Gene Cernan would go into the lunar module. They'd separate from the command module. They would stay in lunar orbit with John Young, and they would descend. They would not land. They would descend at a low altitude over the Apollo 11 site. The lunar module that they flew on this mission was too heavy to land and to get off from the moon. So it was not intended that this was going to be a landing mission, but it would be a mission where we would check everything out with a lunar module in the lunar orbit, and we would fire the ascent stage just as we would on a normal launch from the moon, and then rendezvous with John Young in lunar orbit. And this mission turned out to be quite well. We launched on May 18th, 1969, And this picture was taken by John Young of the lunar module after it separated, with Tom Stafford and Gene Cernan in the lunar module. And they descended to a low altitude over the Apollo 11 landing site and took photographs of the landing site. They fired the ascent stage, which was the upper stage of the lunar module. And here you see the ascent stage of the lunar module, the upper part, coming back up to re-rendezvous with John Young in the command module. And John Young took this picture of Stafford and Cernan coming up to re-rendezvous. So at that point, we had flown to the moon twice on Apollo 8 with a command and service module. We had tested the lunar module in Earth orbit, and we tested it in lunar orbit. And now we felt we were ready to go land on the moon. So the next flight, Apollo 11, was scheduled in July, 2 months later. And it was flown by, of course, Neil Armstrong, Mike Collins, and Buzz Aldrin. And this is a Apollo 11 booster, Saturn V. And this is a launch of Apollo 11. The rocket on top of the command module is a launch escape tower that's used in the case of an explosion. It would pull the command module away from the exploding booster. So it is just jettisoned during the launch phase. So you see it here in this picture, but after the launch, it's jettisoned. So you don't see it in any of the pictures going to the moon or coming back. And this is President Johnson. At that point, he had become president in 1964. And then he had retired from the presidency, and Richard Nixon had become president. But President Johnson did attend the launch, and here you see President Johnson and his wife watching the launch go up, Apollo 11 launch. And they went into lunar orbit, and it was very successful. And Neil Armstrong and Buzz Aldrin went down to the surface of the moon, landed on the moon. They actually, Neil had to take over manually to land in the designated area. Had put him into an area there were some boulders. So he had taken over and flew the lunar module actually to where he could land. And at the point he landed, he was very short of fuel. This is a picture of Neil going down the ladder. We had mounted a television camera on the side of the lunar module, so we were able to watch them coming down the ladder. And here you see Neil coming down the ladder for the first step on the moon. And this is the American flag they planted on the moon. And you don't see any pictures of Neil on the moon, because Neil was carrying the camera. So all the pictures you see on the surface of the moon of astronauts on Apollo 11 are really Buzz Aldrin. There is one that, there's one I don't show you here, but there is one that does show Neil, because there's a reflection in their visor. And so there was a picture that he took of Buzz Aldrin, and you actually see Neil taking the picture in the visor. I don't have that picture here, but it does exist. And of course, when we got the astronauts back on Earth, there was great excitement. And this is the control center, and there was a real bedlam there on a successful landing on the moon. We landed on the moon before the end of the decade, and I don't think we would have been able to do that had we not, George Low had not come up with a sequence that we ended up implementing with Apollo 8. And that really enabled us to make that landing. So we had really achieved what President Kennedy had asked us to do 8 years earlier. And so we felt we had been flying every mission 2 months after on 2 month centers. So we felt that we didn't really need to fly the next mission 2 months on a 2 month center. We relaxed and took 4 months off and flew the next mission, Apollo 12, in November. And Apollo 12 was flown by Pete Conrad, Dick Gordon, and Al Bean. And this mission was a mission that we wanted to take to a specific landing site on the moon, because there are mass concentrations on the moon that were giving us problems relative to our navigation and guidance. And so Apollo 12 was dedicated to landing very close to a surveyor spacecraft that had flown to the moon in 1967. And we wanted to prove our capability of landing on a specific area on the moon. And Apollo 12 was flown to land very close to the surveyor. You've heard about problems we had on launches. Of course, we had a movie made about Apollo 13, and that's become quite famous. But on every one of these Apollo missions, on Apollo 11, we got computer overload, and we had a young engineer that was able to detect the problem and give us a go ahead because he had understood it. And on Apollo 12, we also had another problem. We launched right after a cold front had gone through the Cape launch site. And when we launched the Saturn V and the command and service module, it triggered lightning, and the lightning struck the spacecraft, and we immediately lost all electrical power. We lost our reference, and the crew was in a bad situation. We fortunately had a guidance system in the upper stage on an instrument unit on the Saturn V, so we were able to keep our references for the launch phase. But the crew was in the dire straits. And there fortunately was a young engineer in the control center who had seen something like this happen during simulations. The simulations are training exercises that we run with the crews and with the flight controllers before we fly a mission. And he had seen something like this happen, and he was able to tell the crew to which switch positions to go to, and they were able to recover all their electrical power. And then once we got into orbit, we were able to realign the platform from the instrument unit in the Saturn V. So we got into lunar orbit, or got into Earth orbit rather, and we were concerned about what damage the lightning had caused us on a spacecraft. So we orbited the Earth for a few more times to make sure that we had confidence that everything was working as it should work on the spacecraft before we committed to go to the moon. So we convinced ourselves that the spacecraft, even though it had been hit by lightning, could make the mission to the moon. We launched with the third stage on a trajectory to the moon, and Apollo 12 turned out to be a very successful mission. And here you see the landing of the lunar module. The lunar module's in the background, and you see one of the astronauts going over to the Surveyor spacecraft, which is in the foreground, and he takes parts off the Surveyor. He was able to remove parts from the Surveyor, so we were able to return those to Earth and see the effect of the lunar environment on the metal and the structures of the Surveyor spacecraft. So it turned out to be a very good mission. And we also, of course, on Apollo 11 and Apollo 12, gathered a lot of lunar samples. So even though the mission was focused on landing near the Surveyor, we also did a lot of lunar science and brought back many samples from 11 and from 12. So the next mission we would fly would be 4 months later, and that would be Apollo 13. And that mission was going to be flown in March of 1970. And it would be flown by this crew. Actually, the middle astronaut was replaced 2 days before launch because Ken Mattingly, who was on this crew, had been exposed to the measles during the pre-flight activities. And so it was determined that we did not want to fly him because we didn't want to get anyone getting measles during the flight. So Jack Swigert was on a backup crew, And the backup crew goes through the same procedures and the same training as the prime crew. So we took Jack Swigert and replaced Ken Mattingly, and Jack Swigert flew this mission, which turned out to be his only mission in space. And he became part of the Apollo 13 crew. That's Jim Lovell and Fred Hayes on the left. And Jim Lovell had flown before, but Fred Hayes and Jack Swigert had not flown. And the launch of Apollo 13 went to the picture-book launch, and everything went very well. There wasn't any problem until we got on a trajectory to the moon. And once we got on a trajectory to the moon, the command module did a 180-degree turn, and we docked with the lunar module. So we were fortunately, we were docked, the lunar module and the command module were together, docked together. And we had separated from the third stage, and we were on a trajectory going to the moon. And we had just finished a press conference in flight, an in-flight press conference, and the crew had just finished that activity, and they were asked by one of the controllers in the control center to turn on the pump in the oxygen tank and stir the oxygen propellant. And when that happened, there was an explosion, and it blew out, as we found out later, it blew out the side of the service module. We lost all our fuel cells, we lost electrical power, and we were rapidly losing oxygen. After we deduced that the magnitude of the problem, we felt we had to power down the command module and get the crew out of the command module because we were running out of oxygen, and get them over into the lunar module, which we did. The lunar module had oxygen on its own and also had battery power for operations on the lunar surface. So we had electrical power, we had oxygen, and we could keep the crew alive in the lunar module. But we turned everything off in the command module because if we were going to be successful in getting the crew back, there was the fuel cells had failed, so there was no electrical power but entry batteries, and we wanted to conserve those entry batteries because if we were successful in bringing the crew back around into the Earth's atmosphere, we needed to conserve those batteries and have enough power to re-enter the Earth in the command module. So we got them into the lunar module. The lunar module, we powered it down because we had to conserve power there, and we wanted to conserve the oxygen. And we had already altered the trajectory on the way to the moon. We normally flew what we called a free return trajectory, where you would launch from the Earth and then fly a trajectory that would take you around the moon and then return you to the Earth. But on Apollo 13, we had altered that early in the mission to get to the moon quicker. And so what we had to do in order to get on a free return trajectory to bring the astronauts back to the Earth, we had to do some mid-course corrections. And the service propulsion system, the engine that was on the service module, we felt was going to be affected by the explosion, so we couldn't use that. So we had to use the descent engine, the engine on the lunar module that was used for landing on the moon, use that in a fashion that we had never used it before, as we were using the lunar module in a fashion we'd never used it before. So we used the descent engine on the lunar module to do the corrections that we needed to do. And here you see the trajectory for Apollo 13, the mission profile. We ended up having to do a number of mid-course corrections in order to get them back to land on the part of the Earth that we wanted them to land on, which was in the Pacific. And they went around the moon, and we did our mid-course corrections. They were able to exist in the lunar module. And then as they came closer to coming back into the Earth's atmosphere, they jettisoned the service module. And this is a picture taken in flight. In the lunar module, we had lithium hydroxide canisters that scrubbed the air. And we rapidly ran out of those because they were limited number of those, only for being used on the surface of the moon. But we had more lithium hydroxide canisters in the command module, but they were a different configuration. So if we were going to use them and keep the air in order to really support the astronauts, we had to somehow convert the lithium hydroxide canisters and use them in the system in the lunar module to keep the air scrubbed. And here you see a procedure in a way we had designed it on the ground that the crew implemented in flight to use the lithium hydroxide canisters from the command module in a jury rig fashion to make sure the air was pure in the lunar module. When they did get on the trajectory back to the Earth and getting close to entering the Earth's atmosphere, they separated from the service module. And this is a picture they took of the service module, and you can see the damage that had been created by the explosion. The whole side of the service module had been blown out. And of course, they lost all of their oxygen, lost the fuel cells, and the service module was not able to support any missions. And we did have enough power in the command module where the astronauts were moved back in from the lunar module to the command module. We activated the environmental control systems, and we were able to actuate the chutes, and the guidance system was realigned. And here's Apollo 13 descending to a landing in the Pacific. You can see it coming down. And the mission in one respect was not very successful, but certainly in the sense of being able to return the crew safely to the Earth, it was a very successful mission. And we had to take a good bit of time to try to understand what caused the problem. And we were able to reproduce the problem. The insulation on the wiring that went to the pump in the oxygen tank had been overheated and damaged, and the insulation had been burned off during testing at the Cape. So there was no insulation on the wiring. And when they turned the pump on, a spark ignited the oxygen in the tank, and that caused the explosion. So we were able to reproduce it and find out exactly what caused it. There was an incompatibility between the ground support equipment and the spacecraft that had led to overheating the wiring. So we were able to correct all that. And about a year later, we were able to fly Apollo 14. And Apollo 14 was the second flight that had been flown by Al Shepard. He'd flown the first suborbital flight, Mercury flight, and now commanded an Apollo flight. And here's Al with his two astronauts, Ed Mitchell and Stu Roosa. Al had flown a suborbital flight of Mercury, and Ed Mitchell and Rusty and Stu Roosa had not flown at all. And this is Apollo 14 as it was getting ready to launch, and Apollo 14 being launched, and Apollo 14 on the lunar surface. On the first flights of Apollo 11 and 12, we did science on the moon, and we'd intended to do a good bit of science on 13. And on 14, we wanted to do more science on the moon. And on Apollo 14, we took a small cart with us that would enable the astronauts to carry their experiments and their samples that they collected on the cart as they moved around the moon. So this is a picture of that cart on the moon, where they're able to put their tools on the cart, and they're able to carry their experiments and also the samples back to the spacecraft on this cart that they would pull. And Al Shepard was able to take one of the tools that he used for sampling on the moon and put a golf head on the tool, and he actually drove 2 golf balls on the moon. And according to him, they really went a long way. So he's probably the first astronaut that's first human that ever played golf on the moon. The next flight was Apollo 15, and we were doing missions about 6 months apart at that time. And Apollo 15, again, we wanted to do more science on the moon. And each one of these Apollo missions there was a great deal of effort put into selecting the landing site, because we wanted to try to understand the evolution of the moon and how to relate it to the evolution of the Earth. So we really looked at where we could get samples from the moon that would be different from each of the flights and give us a better idea of the character of the moon in different locations. And so on Apollo 15, we landed in an area where we were in the highlands. It was a higher area on the moon. And on Apollo 15, we took with us a lunar rover, which is a small vehicle that the astronauts could actually drive on the surface of the moon, and gave them more capability to carry experiments and also to carry samples back. This is a crew of Apollo 15. Dave Scott, who had flown on Apollo 9 and flown on Gemini, Al Warden, who had not flown, and Jim Irwin had not flown. And this is the launch of Apollo 15. And this is the lunar rover. It was mounted on the side of the lunar module, and it had wire mesh wheels that tucked in underneath the vehicle. So this is a picture of it where they were testing it as it would be mounted on the lunar module. And this shows how it would be deployed. The astronaut would get down to the surface of the moon. He would pull these chains that would lower it to the surface of the moon, and the wheels would pop open, and then they would gently lower the lunar rover to the surface of the moon. And this is a picture of the lunar rover on the moon. You can see in this picture there's a television camera right in the front, and there's also an antenna. And what we had the astronauts do, they would go to a particular site where they were doing investigations. One of the astronauts would point the antenna at the Earth, and then we would control the television camera, and we're able to observe the astronauts as they performed their duties on the surface of the moon. And the rover worked very well. This is another picture of the rover, and you can see this is in the Apollo 15 landing site. And as I say, it was in the highland area. You can see the slope of the hills. So we were able to get different samples than we had on the other flights. Apollo 16 was flown 6 months later, and Apollo 16 was flown by John Young, and Ken Mattingly, who was going to fly on Apollo 13, got to fly on Apollo 16, and Charlie Duke was the other astronaut. And this is the 3 astronauts. So Ken Mattingly actually got a better flight to fly on than Apollo 13 by waiting for Apollo 16. And this mission was quite successful. This is the lunar rover, a training vehicle that the astronauts used to train on here on Earth. It didn't have wire mesh wheels, it had hard rubber wheels, but they would learn to drive it on the Earth and use it to do investigations, science investigations, to train for the mission on the moon. And here you see John Young driving the lunar rover on the Earth, the training vehicle. Apollo 16 launch was a picture book launch. And this is a great picture taken by John Young of all of North America almost in one picture as he was going outbound from the Earth to the moon. You can see Baja, California, and you can see Houston over in the middle of the picture to the right. And it was a clear day in Houston, and pretty much a clear day across all of North America. And this is a picture of John Young on the surface of the moon. On the surface of the moon, you have a 1/6 gravity, only 1/6 of the gravity you have here on Earth. And here you see John Young taking advantage of that 1/6 gravity, jumping way up off the ground. And we took advantage of it on the ladder of the lunar module. The first rung of the lunar module was considerably above the surface of the moon because the astronauts could actually jump up to that first rung of the ladder. and we could save weight by not making that letter go all the way down to the surface. So here you see John doing a salute as he jumped up in the air. And all the astronauts from Apollo 8 on took this picture of the Earth as they came around in lunar orbit. They took this picture, and you can get an idea of how the Earth looks against the black background of space. And this picture was first taken on Apollo 8, and I think it caused a great deal of awareness about the environment of the Earth. People became more sensitive to the environment. As you look at our Earth, it's a jewel against all the black background, and we need to make sure that our environment is taken care of. And this picture and its predecessor on Apollo 8 certainly emphasized the point that Earth's environment is important. And this is the landing, actual landing of Apollo 16, splashing down. The last Apollo mission was Apollo 17, and it was flown 6 months after Apollo 16. And Apollo 17 had Gene Cernan, who had flown on Gemini, and had 2 new astronauts, Ron Evans and Jack Schmitt. Jack Schmitt was a geologist, and this was his first mission in space, and he was going to the moon and would actually be able to do geology on the moon. And Ron Evans, this was his first flight. And of course, they did training here on Earth for their excursions from the lunar module, going to locations here on the Earth. There were similarities to what they would find on the moon. So each of the traverses on the moon was well planned, and samples were expected to be picked up at different locations. And so the crew trained well here on Earth in order to be able to perform that mission well on the moon. And here you see Jack Schmitt and Gene Cernan going through training here on Earth. Also here on training in their spacesuits here on Earth. The ascent stage, as I said, was the upper stage of the lunar module. The descent stage had a propulsion engine that did the landing, but then the astronauts would be in the ascent stage and would fire an engine in the ascent stage to lift off from the moon. And so when we wanted to get a picture of the actual ascent of the lunar module from the moon, the ascent stage, we got the astronauts to position the lunar rover in a position where we could actually aim the camera and get a view of the launch of the lunar module. And this is a picture of the actual launch from the moon of the ascent module. It was taken with a television camera from the lunar rover. And the 2 astronauts would launch from the moon, go up and rendezvous in lunar orbit, and they would rendezvous, in the case with Apollo 17, rendezvous with Ron Evans, who would be orbiting in the command module. And this is the landing of Apollo 17, the last of the Apollo missions. So we actually flew 9 missions in Apollo. Actually flew 6 missions to the moon, 3 missions that went around the moon, and 2 missions in Earth orbit. So we did a total of 11 flights, 9 flights to the moon, 6 landings and 3 orbiting the moon, and then the 2 Earth orbiting flights, Apollo 7 and Apollo 9. And then, of course, Apollo 1 was a mission that we lost on the ground. And here you see the different landing sites that where we landed on the moon. And as I say, they were all in different locations, and we wanted to characterize the samples from the moon. And we have all these samples in Houston, and we still have investigators looking at these samples. They're sent out to investigators all over the world, and we have a lunar science conference each year in Houston. And it's gotten bigger every year since Apollo. And our Russian colleagues have been there. And of course, they got samples from the moon as well. And they are usually regular attendees at the conference. But you see Apollo 15 was up further north. Apollo 17, Apollo 11, Apollo 16, Apollo 12, and Apollo 14. So we put a lot of effort into trying to pick different landing sites in order to really get a different character of samples that came back from the moon. The program was very successful, and we achieved what the challenge that the president had given us to land safely on the moon and return astronauts to the Earth before the end of the decade. We actually flew 2 missions, Apollo 11 and Apollo 12, before the end of the decade. We had also planned on flying 2 additional missions, but President Nixon decided to cancel those missions, so Apollo 18 and 19 were canceled. And those flight vehicles are on display. One is on display at the Johnson Space Center, and one's on display in Huntsville, and one's on display. There's another one on display in the Kennedy Space Center in Florida. So if you have the opportunity to visit any of those sites, it's very interesting to see the Saturn V. It's a 363-foot tall vehicle. It was a great booster that performed very well for us on Apollo. So the Apollo program was a great experience for me, and I think I look back on it with very fond memories, and work with a lot of fine people, and I hope that we can get back to the moon, and this time go back to the moon together. It was interesting to note that President Kennedy appeared at the United Nations in right before his assassination in 1964, and made a speech about going to the moon with the Soviet Union. And he actually wrote a memo that before he was assassinated, about a week before he was assassinated, saying why, asking NASA and his cabinet why we shouldn't modify the Apollo program to bring the Soviet Union into the program. He was assassinated, and of course that memo never got answered. But as we look to going back to the moon, I hope that we can do that together, as we have proven on the space station. Working together in international cooperation is a much better way to fly in space. And that, I think, has been the great thing about the space program, is that it started out as a competitive space program between the Soviet Union and the United States. And the great thing about it today is that we're working together with our Russian colleagues and flying together on a space station. And it's been a great relationship, and we look forward to continuing that as we go explore the heavens beyond Earth's orbit. I hope that we can do that all together. So thank you very much.
Thank you so much, Mr. Ebi. Questions, please?
Before asking questions, please introduce yourself when you ask a question.
We have Maxim Lysenko from Bauman University. Please have a word.
Hello. I just want to ask about movies what we have about Apollo missions. It's First Man. Recently I watched them. How close it to reality?
Dmitry, repeat, please.
So,
Oh,
Mr.
yes.
Rebbe, there was a question about the movie, as I suppose, Apollo 13.
Yes.
The question was how this movie corresponds to the reality.
It was a very interesting movie, and a lot of liberties were taken with the movie. NASA did a movie about 2 weeks after each flight, and there's a set of movies on all the Apollo flights. And I'll have to get Victoria a set of those so she can actually see the actual movie that was made of Apollo 13 2 weeks after Apollo 13. But people in Hollywood are really looking for entertainment, so they took to some liberties, and it didn't quite happen the way they portrayed it happening, but it was a very entertaining movie.
Thank you.
Okay, now we have a question from Curtis Clark from USA delegation, please.
Hello, my name is Curtis Clark from the United States. Looking at this map, it appears almost like all the Apollo missions are like on one half of the moon. Did you not land on the other side?
No, we didn't land on the backside of the moon. We didn't have communications on the backside. And I think as we look going back to the moon, we're going to have some relay satellites that would allow us to land on the backside. There were scientists that were interested in landing on the backside, but I think most of the engineers in the program were very uneasy about doing a descent and landing on the backside without any communication. So the landings that were all made, they're all made on this side of the moon. But I think there are a lot of interesting sites on the backside that I hope that we can land at and get samples from those sites as well. But it would require, I think, having a relay satellite where we could have communications for the landing.
Thank you.
And now another question from USA delegation, Chloe Tovar, please.
Hello, sir. I'm Chloe Tovar from the University of Houston. I'd like to ask about the flags that we see in the pictures. In all the pictures that we see, there's one of the United States flags. And I was wondering, so did you leave a new flag every time you went to the moon? And did you leave anything else on the moon that's sort of the same nature as the flag?
Would you repeat the question?
Okay, so did you leave a new flag every time you landed on the moon? And did you leave anything else on the moon that had sort of the same nature of the flag that was kind of a personal thing instead of maybe science and nature?
Well, we left on the moon on Apollo 11, and on other flights we left mementos on the moon from all the countries here on Earth, and so the astronauts also left some mementos from for the astronauts that had fallen, that died, and so there are some mementos on the moon that were taken by the crew, each of the crews. And of course, we still have the lunar rovers. 3 of the lunar rovers are still sitting on the moon, and probably their batteries aren't in too good a shape right now, but if you replace their batteries, you could probably get them up and running again.
Thank you.
Okay, then Luba Joe from Bauman University, please.
Hello, sir. My name is Bojo. I'm from Bauman University. My question is, can you tell us more about radiation and thermal protection for Apollo spacecrafts? Thank you.
What was the question?
Can you tell us more about radiation and thermal protection systems for Apollo's spacecrafts?
Well, we had a network where we monitored the radiation in space before each of the missions and during the mission. So we tried to accomplish our missions during minimum radiation periods. And of course, the astronauts carried dosimeters with them, and we very carefully really got a good idea of the exposure they got on each of their missions, not only on a mission to the moon, but on Earth orbital missions as well. But we, with the network, we had to try to minimize radiation during periods of minimum radiation. We were able to do that on the Apollo missions, and that was fortunate.
Okay, thank you.
And now, please, Jorge.
Sorry, I'm Jorge, and my question is, what would be the best approach for like a space program development? Is it really cooperation the best idea, or is it like, I don't know, well, I understand it's impossible to create a fierce competition like the one that you had during those times between the United States and the Soviet Union, but do we really need like so much the cooperation, or we just need, I don't know, some influence of competition, of wanting to be the first, wanting to be better, to get better results in the space programs in general?
Well, I think if we're going back to the moon, I think the way that I think that we should go is with international cooperation, and much as we're operating on the International Space Station, and all of the partners contributed to the space station, the building of the space station, the operating of the space station. And I think we can really come up with a program that gets us back to the moon in a minimum time and takes advantage of the capabilities of the countries, Russia and the Europeans and the Japanese and the other nations that are involved in space. And we should do that. And I think cooperation is the key to the future of space exploration.
Thank you.
And next question from Patrick Lamoche from Bauman University, please.
Oh, thank you. My name is Patrick Lamoche, and I'm a student of Bauman State Technical University. Mr. Abbey, I would like to ask you about the atmosphere inside of the crew cabin. You mentioned that the atmosphere was very much oxygen rich. Could you please say why was this the case? What is the reason behind this oxygen rich atmosphere, and whether it was changed after the Apollo 1 tragedy?
Well, we flew with 100% oxygen in Apollo, and in Apollo 13, of course, we had our oxygen provided to us in the command module from the tanks in the service module, so we lost those when we had the explosion. The lunar module had oxygen, and we were able to take advantage of the lunar module oxygen and on Apollo 13 and use that to provide oxygen for the command module for the crew coming back in. So we were fortunate that we had the lunar module still attached to the command module when we had the problem. I think we would have had a difficult time getting the crew back without the lunar module. But the oxygen problem that we had on, of course, on Apollo 1 with the fire, we had unfortunately not paid enough attention to the flammable materials that we put into the spacecraft. And with the flammable materials in a 100% oxygen environment, you're going to have a problem. So we were able to come up with new materials, and those new materials are used in airlines now. All the airliners use those materials, They're used in children's pajamas and all kinds of other applications, the materials that we developed on Apollo. So there's been a great benefit, I think, from all those materials, and we didn't fly anymore with 100% oxygen after Apollo. So we did not fly with oxygen and 100% oxygen in the shuttle.
Right. Thank you very much for your answer.
And now another question from USA delegation. Dimitri, please, you have the word.
Thank you. Hello, sir. My name is Mitch Janasopoulos. I'm from University of Southern California, United States. My question is more sort of a general kind of career question, as one of my goals one day is to become an astronaut. For someone like me, or for any aspiring young students that want to become an astronaut one day, what is one of the advice you can give us to, as we start taking our first steps in our career, to get through that goal?
Say again?
Sort of, what is an advice you can give to aspiring young students who want to become an astronaut one day? Sort of, what can we do after college to get there?
You're broken up. I didn't catch what you said.
Oh, sorry, my internet connection might be bad. I was just asking advice for what students can do after college that are aspiring to become an astronaut one day.
What? I didn't get the question.
Sorry, the question was, this man is a student and he asks you to give an advice what he or she should do to become an astronaut if he studies in a college now.
He's a student and wants to be an astronaut?
Yeah, so he asks for some advice maybe.
Well, I think that having a good engineering or a science background is very important. And I think having the ability to work well with a team of people is very important, because astronauts, as they perform in space, really work as members of a team. And so if they're doing experiments in space, they do other people's experiments in space. So they need to be of a temperament that works well as a team member. And you also want to have gained operational experience and get some understanding of what it takes to train and prepare for space flight. And getting experience in the control center in Moscow or in the United States gives you a very good understanding. And also participating in as a trainer in at Star City or here in Houston. a number of our astronauts have moved from being flight controllers or trainers into becoming astronauts. So they have good technical and science backgrounds, and they have good operational backgrounds, and they have a record of working well as with a team. And I think if you really want to focus on being an astronaut, you want to try to acquire all those skills and develop them as best you can.
Thank you very much.
I think that was the last questions. I don't see if anyone wants to ask something else. Actually, in my turn, I'm Galina from Bauman University, and I wanted you maybe to say, can you say a couple of words about Soyuz Apollo mission, because it's 45 years anniversary of that mission was like in 15th of July, in the very beginning of our program. Please.
You had a question?
Yeah.
No, it's not like the question. I just wanted you to say a couple of words about Soyuz Apollo mission.
about the missions.
Soyuz Apollo.
Oh, the Soyuz Apollo. Oh, well, that was, we started working on Soyuz Apollo back in the early 70s. And George Lowe, who was the program manager for Apollo, was one of the ones who really started that effort working with the Soviet Union because he felt it was very important for the two countries to work together. And so that led to really Bob Gilruth and a team from the Johnson Space Center going over to Moscow and sitting down with their colleagues there, and they came up with a plan to do a test project where we would develop a common docking system that both the Soviet Union and the United States would use, and it would be available if the Soviet Union had a problem in space. We could dock with their spacecraft and provide a rescue capability, and they could do the same with ours. So we developed a common docking system, and that was really an outstanding docking system, and that docking system is still used today on the International Space Station. And Vladimir Sementnikov was a leader of that effort, and he did a great job on the docking system, and has written a book about docking, and I would commend that book to you all. It's a great book. But the Apollo-Soyuz test project, I think, really laid the foundation for what we're doing today on the International Space Station. We established good working relationships with all our counterparts in the control center in Moscow, and Star City with the trainers, as well as all the cosmonauts, and it was a great program, and I think that we didn't continue the relationship after Apollo-Soyuz. It was a little while before we renewed our relationship, but I'm glad that we were able to finally do that, and it was very good to find our same colleagues that we'd worked with on Apollo-Soyuz. We're still there. We're still working hard on the space program, and I've enjoyed seeing them and being with them. And as I say, it's really been the foundation for what we're doing today on the International Space Station.
Thank you very much. And we have maybe one last question from University of Houston, from Kelly Graham. Kelly, please, can you say it yourself?
Yeah. My friend Harry was wondering, what was one of the best memories that you had when you were working during the Apollo missions? And it's from the University of Houston's American Institute of Aeronautics and Astronautics branch.
What was the question?
What was one of the best memories you had when working on the Apollo missions?
Did I what on the Apollo missions?
Yeah, what is your favorite memory from working on the missions?
You're breaking up. I can't hear you.
Mr. Rebbe, the question is about what's your favorite memories while working over the Apollo missions?
I think certainly I had the Apollo fire was a very sad memory, but I think Apollo 8 was a highlight for me. The first time that we ever flew a flight out of Earth orbit and got to the moon, and I think in many ways Apollo 8 was meant more to me than Apollo 11, but certainly landing on the moon was very important. But I've got great memories of all the Apollo flights, but probably that Apollo 8 mission, which led the way really and got us started on really being able to go to the moon and land on the moon. It was that mission was one that is in my mind and I remember very well.
Спасибо большое, мистер Эбби. Хочется поблагодарить вас от всей души, от всех наших участников за ту прекрасную лекцию, что вы нам дали, и за тот труд, который вы вкладываете в эту программу.
Dear Mr. Abby, thanks a lot for your lecture, and especially I would like to greet you very much about your efforts that you provide us for this program all these years.
И очень хочется надеяться, что наши участники также подружатся, как подружились когда-то Томас Стаффорд и Алексей Леонов, как дружат наши астронавты и космонавты, как они вместе делают большую, трудную работу. Это пример для нашего сегодняшнего молодежного мира, и надеюсь, что мы с вами внесем свой вклад в развитие этих прекрасных отношений.
I also would like to add that I hope that the example of friendship between Tom Stafford and Alexei Leonov, the multiple examples of friendship between Russian, Soviet, and American astronauts will be the way of how our US participants of this summer school should behave in future. And I hope that our US people will continue these friendship traditions in their following professional life.
Спасибо вам.
Thank you very much.
I think this is really, you have a wonderful program, Victoria, and I am feel very fortunate that we can be a part of it. And I hope we can be a part of it for many years. I think it's a life-changing experience for our students, and I look forward to participating with you for many years to come.
Thank you. Thank you. А теперь, дорогие друзья, в завершении нашей лекции прошу всех включить камеры, и мы сделаем общий снимок на память. Дмитрий, пожалуйста.
Just at the end of our meeting, please, all the participants, switch on your cameras, and Galina, as I suppose, will start to come up with the final collective picture. Galina, please give a comments.
I got the first one. Curses, you're okay. And the second.
Well, thank you all for your patience in listening to me this morning, or this evening over in Moscow. And I feel very fortunate to be a part of the workshop this evening in Moscow. And I wish you every success for the rest of the program.
Thank you. Thank you very much.
Screenshots are taken as well, so we can say goodbye to our friends.
Goodbye, guys.
Goodbye.
Bye-bye.